We've gone through 3 properties of logs so far. Now we'll look at a 4th property of logs. Just to review, the ones we know so far are that 1, the units of measurement do not affect the value of r. If you change from feet to meters, for example, only use r when the form is linear. Like they said, you first plot the data, plot all the ordered pairs. If it looks linear, then calculate r. If it doesn't look linear, figure something else out. Something from a future statistics class you might take, or a different class. The third is from the previous page, r does not give us information about form. We cannot determine a relationship is linear by looking at r. Now we examine a 4th property of r. Outliers affect r. The correlation is heavily influenced by outliers, kind of like the mean of data. Remember, if we had a bunch of data, I think we saw examples where a lot of it lined up. This is not a scatter plot anymore. This is now, what do you call it? A dot plot, where I have a bunch of values here, I have a bunch of values here, and then maybe a few off over here. The mean is not affected by those outliers that are way off over there. Or sorry, I should say the median is not affected. Median will stay close to all the majority of the data values, but the mean will be heavily influenced and will be pulled towards the outliers. I think we saw that in examples. An outlier can increase or decrease the value of r. The effect on r depends on whether the outlier is enhancing or detracting from the linear form. So for example, I guess if the outlier, let's say most of the data lines up in a line and one outlier is far away, but it's still kind of as close to that line anyway, even though it's not close to the rest of the data points, then that could be fine. But if the outlier happens to be way out, not even close to the line that we think fits the other data values, then it's going to hurt r quite a bit. Outliers that decrease the value of r. Now we'll look at that. Using the applet below, let's explore how an outlier affects the correlation. We'll read the instructions below on the applet. Okay, first it says we're going to click on the graph to add data points. Create a scatter plot with about 10 points that have a strong positive linear relationship. We'll pay attention to the correlation coefficient calculated at the top left of the applet. It should be something close to 1. Clicking on the garbage can lets you start over. Okay, then we'll create an outlier that deviates from the pattern. Click on one of the data points in the upper right of the graph and drag it down along the right side of the graph. Again, pay attention to what happens to the data value. Okay. Let's see here. Oops. So I'm going to just plot random, kind of random points, but I kind of want them to line up in basically a line. And you can notice that here, it's calculating r as we go. I'm kind of making it a little bit random because I don't want it to be perfect, but yeah, making it more interesting. Okay, now how many do I have so far? 5, 6, 7, 8, 9. Oh, 9, 10. This is fairly good. I mean, that r is close to 1, which means that these line up in a fairly linear pattern. Also, r is positive, so it looks like the line that will fit this data best will have a positive slope. Then it says now drag one of these data values down. Notice it was 0.97. I'm talking about this number here. But as I pull one of the data values down, notice that the r is getting smaller and further from 1. This is going to be an outlier now that I'm pulling it down. It was 0.97, now it's 0.9 and 0.8 something. And now if I pull it really far, 0.6. So it's getting closer to 0, which means maybe that one outlier is making this so that maybe a linear relationship doesn't work. So sometimes I think it might be good to forget about one outlier and just think about the rest of them and figure out what r is for those that aren't outliers and stuff like that. Anyway, what did this activity illustrate? This activity illustrated that the correlation decreases when the outliers deviate from the pattern of the relationship. By dragging a data point from the upper right to the lower right, you created an outlier that does not fit the positive linear association in the rest of the data. This decreases the strength of the linear relationship and causes a decrease in r. Outliers will not always decrease the r value. Some outliers can increase r and make the association appear stronger than it really is. Now look at an example where outliers increase the value of r. We'll use the applet again, but we'll go back first and clear the data points, get rid of those 10 we had. You should try this too when you're done watching this video. It's kind of interesting. We'll create a scatter plot with about 10 data points that have a fairly weak positive linear association. So kind of like the points I put, but I won't put them so close to the line that would fit them. I'd put them a little bit further away, but they still have some kind of association. With the small r, something like 0.2. But this time, keep the data points grouped in the lower left corner of the scatter plot. Okay. Now we'll add another data point in the far upper right corner in the scatter plot, away from the rest of the data, but I think we're trying to keep it close to that line. Imagine what the line would look like and put a data point far up to the top right. The data point is an outlier, but it's an outlier with respect to the X and Y values. It does not respect the linear form. Let's go see. Okay, I'm going to click on the garbage can at the bottom, and then now do a bunch of points kind of in the bottom right, or sorry, bottom left area. It looks like my relationship is too strong right now. They said keep it closer to 0.2, so I'm going to try to put a few points down here that are further. Oh, that's a little too far away, I think. How many is that now? 3, 4, 5, 6, 7, 8, 9, 10. I got 10. Okay, my R is still a little bit too big, but wow, what are you going to do? It's close. I guess I could drag. I'm going to drag one of the points away. Oops. Yeah. I want my R to be about 0.2, so I'm going to take one of them that's really close to a line that would fit the data and pull it farther away until I see 0.2 on there. Something like that. It doesn't have to be perfect, but that one kind of messed things up, but that's okay. But I'm trying to make it so it looks like this lines up in some kind of line. Like, I guess this would kind of fit the data. Most of the points are close. This guy's not so close. This guy's not so close, but they're not that far away. And then they wanted us to now click on one more data point that's kind of still on that line that we drew. I should have kept it up, but oh well. Something like that. So notice it went from, it was, let's see, it was 0.2, right? The R value. Now that I've put one more point that's even outlier, it's really far away, but it still kind of looked like it would have lined up on that line that I had created. It looks something like this. It's kind of close to it. But the R all of a sudden became a lot stronger. That's crazy that 10 data values together give you an R value of 0.2. I just added one more data value far away, and it changed R from 0.2, which is almost like the linear relationship is not good. It's terrible. And now I've put one more point. It's become 0.81, which is fairly close to 1. Now it's almost like the answer has changed. It was before, no, maybe a line isn't a great fit. And now it's, oh no, a line would actually be a great fit. That's kind of interesting. So what happened to the value of R? This time you should see the value of R increase after the addition of the outlier. This makes sense because the outlier is making the form of the data more strongly linear, so R increases.